Andrew Sage. I'm from Franklin County Mosquito Control. I am the Wetlands Manager and Lead SUAS Pilot and Control. I apologize, this is still in window mode here. So this is basically when we first started this exploration into UAS. This was basically kind of the feel we'd get back from it. I'll breeze through these first parts here. So in 2017 at the AMCA in San Diego, during the lunch break, all the vendors were out, and spotted a drone. It is a rotary prop, large drone, and I got excited. So on February 17th there in the morning sessions, Bill Reynolds and Piper Kimball presented the unmanned aerial systems in mosquito control. And it was kind of eye-opening. It became pretty apparent that UAV tech was going to increase the efficiency and reduce our overhead if we could get it in operation. Of course, that means less footprint, and that means a reduction in our overhead from field personnel to equipment and product. So I decided to bring it up to the boss. Had an idea, thought that we might be able to push UAVs in the wetlands for getting rid of floodwater mosquitoes, and it just didn't fly. So I continued on. I sent some which have periodicals and studies, and it's still, we had a season to focus on, so it still was kind of grounded there. Another pun. Then in 2019 at the 85th annual AMCA, there were just a lot more, there was a lot more information to be had on the subject. We had several speakers, and my director, Dave, finally sat in. And enthusiasm was brimming. We started looking more at the agricultural industry and how they kind of helped advance and pave the way. Of course, Placer County had already begun UAV operations, and another district in northern Idaho had begun UAV operations. Mostly, I believe it was for surveillance, and of course, Placer County was doing liquid treatment, and what we needed was granular. So in 2019, Dave began his own research. I delved a little bit deeper into research and how we could utilize a drone as a primary tool instead of what you'd consider a niche, replacing the backpack and the quads for a UAV as a primary tool. So we started studying. We contacted FAA, other districts. We got into rules and regulations, guidelines. A lot of that's already been spoken about with Scott, and Banu spoke on some of the calibration aspects of it. And it is a process, and I know it sounds daunting, but it turns out that it's not as bad as you would expect. I'd say from inception to application, we were in it within a year. So we contacted the FAA and narrowed down all the specifications, all the logistics. Those other districts that already paved the way wound up being a big help. And then we get to the study aid and actually getting ready to take that test. I'll be the first to tell you that there's a lot of information on that initial 107, and I encourage every district to get into these kind of programs, but it's really not as bad as if anybody would make it out to be bad. It's just it's not hard. It's just a matter of coalescing all that data and all that information. So 2020, last year, actually it was the end of 2019. Our director, our board gave us approval. We got a small drone, a DJI Maverick Air, and which actually became pretty useful in surveillance and also determining the edges of our maps or spray blocks, or treatment blocks rather. And so we still use it, but that allowed us to familiarize ourselves with controls, and gave the swamp donkey a chance to get a rest before we put it into application. The DJI Agris MG1P is what we went with. Obviously, Placer County had the S, and a lot of the information and advice we got was off of Placer County. You can see it fitted here with a granular application. It comes with the liquid application. Down here at the bottom, you can see the Maverick Air. The battery time on this is 20 minutes. I know Banu spoke about battery time and any restrictive aspects to that, but with that 20 minutes, we're able to get 1.5 to 2.5 acres of treatment, and that's depending on obviously environment, product, wind conditions. So the FAA requires 2 operators to operate a drone for agriculture pesticide purposes. What we did, we had 2 pilots test, or 2 people test, myself and another employee. And so using those 2 pilots, when you initially get that drone or that UAV, it's extremely helpful. You have the same knowledge base, and so any missteps or any ideas can be bounced off of each other with a good amount of efficacy. So when we got used to the elements of the mapping, the functions, the settings, controls, and the handling, which actually is not problematic, you wind up finding out that you learn a little bit more, because every setting does something else to another setting. And then of course you have updates to contend with. And I wouldn't say so many issues, but just getting things in sync and finding the right settings and parameters that work for you and what you want to do. And I'll get into that more here in this next slide. In the end, we did find that it's a user-friendly platform and is as adaptable as we are. There was plenty to learn, but it's really not that bad. So we would also like to thank Drew Hunter. He was a big help with the calibration. Now, Banu spoke on this, and I will go to the next slide for a brief second. You can see we did utilize the totes for our calibration, obviously perpendicular to a flight path. Flight path is into the wind. That's already been spoken about plenty, but initially we just at the home base at the office, we set a grid, mapped a file, loaded the hopper up with a NERT product, and tried it out to see what kind of action we were going to get out of it. And then of course getting your proper speed and height is kind of a well, it's a cumbersome process, but we got the hang of it pretty quick. Gate opening is a big deal. So this was our final swath analysis for metal arb, or with metal arb, and we wound up at 40-foot height. We operated about 14.7 feet per second, which is about 10 miles an hour. It's actually exact. So we get 40 foot of height, 10 miles an hour. We get a 40-foot swath, and that gives us our 4 pounds per acre of metal arb, and it's extremely consistent, more than a backpack's going to get you. So you set the catch totes up in a line, you get your speed, gate, and height adjusted variably to match your label, and you just repeat and repeat and repeat until you get the correct settings to move you forward into application. And on this particular day, had a little bit of a mishap. This was actually one of the first actual calibrations we did. When your controller starts screaming at you in a foreign language, listen to it and then change that language back to a language you understand. So this is the final application of metal arb. I'll play this for you. You can see this is exactly what you see. Pretty good distance. You have to keep your eyes open. Your visual observer will will play a huge part. It doesn't take this many people to run it, like I said, just 2 people, but that's the whole landing process there for you. And that's that. And then we have a takeoff. And you can see it adjusts itself. This autonomous flight on the takeoff goes up nice and slow. When it comes down nice and slow. And then, of course, you can manually change that. I mean, you can go from autonomous to manual operation pretty quick, but probably not recommended so much. So we go through all of that to get to field operations. Contending with the logistics I haven't heard a lot spoken about that. There are plenty of things to contend with a drone, but it's by no means unmanageable. You go through a lot of trial by operation. Obviously, like I said before, the 2 pilots, actual certified licensed pilots, 107 pilots, is extremely useful. Trial and error and more error until you get to that success. So these are, I'll just breeze through this. This is our general logistics. I'll let you focus on that for a second, but it's all pretty self-explanatory. You have your drone. We opted for 10 batteries. That makes sure that you always have a battery charged and ready to use. And obviously carrying it, protecting it, cleaning it, fixing it if it goes bad. More of the same. So this is what we came up with here. We went through all of that, all the research, studying, testing, the certificates of waiver and authorization to the waiver applications, the calibration, all the malfunctions, although minor, still have to contend with, to get to 93 operational hours with 953 operational flights. Of those 953 operational flights, with those 953 operational flights, we got 1,743 acres treated, a noticeable reduction in trap counts, more sites treated with positive results, and we were able to create final SOPs based on those results, and we are looking to the future. Here's to the future. Maybe not that future. So this is a view from the controller. You can actually see the product come out. As this gets further away, this becomes extremely useful. These are all pre-mapped, just like you heard before in the other UAV talks. All these grids are pre-mapped, and operation is incredibly smooth, incredibly accurate. That's the same thing you're looking at there behind these, behind the sage and these trees.
Andrew, you have 1 minute left.
All right, well, we're at the end anyway. So what we learned, train with intent, definitely improvise, adapt, and overcome. Because of our positive results, we are adding to the arsenal, purchased another drone to utilize, and building new relationships with other districts, extremely important. And yeah, don't keep it to yourself. We're all about sharing and getting the exploration underway so more districts can get in on this. And that is it.